today. You want to tell us exactly what is cosmology?
Yes, the word cosmology comes from the Greek language. Two words in there. The word cosmos and the word logia. The word cosmos meaning the universe and logia meaning to study. Together, cosmology, and the strict usage of the word would mean to study the universe as it is now, or to observe it, to study it as we can observe it now. Furthermore, to like humanity's place in the universe.
And the universe is a very broad place, which means a lot of broad ways you can go about studying cosmology. Like how ancient Greeks used to do it with philosophy, and some still follow those beliefs today. A lot of people believe their religious beliefs, but we're going to focus more on the science aspects of cosmology, just because that's what our theories can prove.
Yeah.
Right? One of those theories being how our universe not expanded, but originated.
Yeah. Oh, it was created to what it is now.
Right.
That theory was the Big Bang, to where there was one small particle, and it was in the center of the universe or on the edge or anything, because there is no edge and there's no center. It just was. It was small, but that's just what everything was. It was very compact and dense and hot, because everything was jam-packed. Like when you get too many people in one car or something, like, it's jammed.
But whenever he says everything, he means everything you can think of. Every
Yeah.
blade of grass, every ant, every star, every planet, every galaxy. Everything you can think of was all packaged as one molecule.
Yeah. Now, that molecule expanded to create what we have now today, to create everything he was talking about. Because in the beginning, there was just there was like probably the first 4 elements in the one, everything we have today, all the matter, but just all the elements were there.
Main ones being hydrogen,
Helium, and I think a little bit of iron. Cool stuff.
iron.
I think so. Nitrogen? Nitrogen. Well, it's okay. Anyway,
Right.
that's just what happened. I mean,
But the name Big Bang was actually a misdemeanor,
yeah, there was no big,
and there was no bang.
yeah, it was
Alright.
everywhere at the same time, and it wasn't a violent explosion or anything. It was just everything expanded out.
Exactly, it's all about expansion. Alright, we know about expansion because today we look around at all of the galaxies and stars and we see them moving away. They're moving away now, then we know that yesterday they were closer together. They were before that, even closer, until eventually they were all in that one molecule.
Yeah.
So when did this molecule exist? How long ago was it? How old is our universe? Alright, there's 2 things involved in calculating how old our universe is. One is finding the oldest star possible that we've been able to find. Alright, finding its rate of expansion, how far it's moving away from us, or not how far, but how fast the distance is covering. And then backtracking that to the time that we would have been in the Big Bang, and that one molecule all together mixed into one. Now, by doing this many astronomers have found our age of the universe predicted to be about, what was it?
13.7 billion years.
Yeah, 13.7 billion years old. Now that is very, very old, considering that mankind has only been here roughly, not even a million?
Like about a billion years. No,
I swear.
well, mankind, but Earth.
Alright, Earth. So, older than any of our ancestors that you could ever imagine.
Yeah.
Before that, this great immense universe is being created.
Through laws.
Exactly.
The first 4 laws.
And it's expanding every day. So this universe is expanding every day. Is it going to keep on expanding? What's the fate of our universe? Some people do believe in infinite expansion, alright? Which is actually very possible. It's all about the rate and the momentum of our expansion, how it's moving, alright? And the force of gravity. Now, if gravity is too strong, and it all depends on the density and mass of everything around us.
The ratio that we have.
Exactly. Alright? And it's above the critical density, which is 6 hydrogen to 1 cubic meter. Then it is very likely that our universe will end in a big crunch, as they call it.
Yeah. Show me a rubber band, or...
Pretty much, that's just saying that our universe, much like this rubber band, is expanding and expanding. Alright? Until gravity is going to make it so hard, it's just going to collapse right back in on each other.
So, pretty much, this could be the Big Bang, the rubber expands, it keeps expanding to a point of critical mass to where it just can't expand anymore.
And then one day, it's just going to snap.
It'll snap,
And then,
it'll just jam pack completely as it will just crush back up into once it came.
when that happens, what's going to happen to us? I mean,
We truly don't know. We hope it doesn't happen. But
exactly. But maybe it doesn't have to happen. Because what if, alright, the critical density isn't reached? What if there's enough low density and gravity in the universe, spread far enough, to where it won't cause that to happen? Will the universe keep expanding? Guess we're just going to have to wait and find out, huh?
yeah.